Alrighty, so we're going to go ahead and start with number 5 here on the next page. It says if you roll a single fair die, what is the probability of getting a 2 or an even? So I have all the possibilities 1 through 6, and I circle all the ones we're looking for, 2s or evens, and it looks like there's 3 that we want out of 6 total. So that gives us, 1/2 or 0.5 or 50%. Whichever way you want to look at it. If you move on to number 6 here, it says suppose you draw 1 card from a standard deck of cards, so there's 52 cards in the standard deck. What's the probability that the card is an ace or the king of diamonds? Well, how many aces do we have in the deck? We have 4 different aces. We have an ace for every suit, and there's 4 suits. How many king of diamonds are there? There's really only 1 king of diamonds. So if we add those 2 together, there's 5 different cards that we're looking for. It can either be one of those 4 aces or that king of diamonds. So there's 5 cards we're looking for out of 52 total. So we get 5 out of 52, and that would be the probability, and you could go ahead and put that into your calculator, 5 divided by 52, and get a decimal, and then maybe move the decimal over 2 spaces and convert that to a percent. It's kind of up to you how you want to represent the probability, but that would be the answer there for number 6. So let's move on to number 7. For number 7, we have a class of 60 students, and 23 of them have brown hair. We have 7 who have green eyes, so we'll put that down. And then we're going to start using this notation where we say, I guess, it's kind of like using set notation. If we have 23 are part of a set or a group called B, and 7 are the green eyes and they're part of the group G, then the ones who have both, they have blue or brown hair and they have green eyes. We represent it with this kind of this thing here. It's just called the intersection between the 2 groups there. So it says what is the probability that a randomly selected student either has brown hair or green eyes? So this symbol here is the AND symbol. They have brown hair and green eyes. And then this union symbol is just what we call the OR symbol. So they can have either brown hair or green eyes. They just have to have one. It doesn't matter. And the equation to find the union is you add the 2 groups together, and then you subtract off this, the intersection is what we call it, and that's where they have both. So we do 23 plus 7, and then subtract off 3, and then we get 27. And so that's the answer there. Alright. So for number 8, we have that table again with these houses that are being sold, but now we have what we call conditional statements. Okay, so what happened? What's the probability that one thing happens, given that this other thing has already happened? So for A, it says, the probability that the house has 3 bedrooms, given that it was sold in 2012. So we know for sure that this house had to have been sold in 2012. So now what's the probability that it had 3 bedrooms? So out of all the houses sold in 2012, there's 54 of those, and we're looking for 16 out of those 54. And so this is just notation that I'm writing down here, and this is the probability of A, which is the event that it has 3 bedrooms, and then this bar here is given that it has, or that it was sold in 2012, given B. And the equation for that is you want to look at the intersection of the 2, that 13 bedrooms sold in 2012 and there were 16 of those, and then the probability of B happening, which is that it was sold in 2012, is 54. So we have 16 over 54, and we reduce that to 8 over 27. So for B, we want to know the probability that the house has 5 or more bedrooms and was sold in 2009. So that's how we get this kind of notation here. It's the probability of A and B. And in this case, maybe A stands for 5 or more bedrooms and B is sold in 2009. So you want to know, what's the probability that both of those things happen. So we look up at the chart and we look at, in 2009, and then you look at 5 or more, and there's 3 of those. So, and that's out of the total because it wants to know, what's the probability that it was kind of sold in 2009 and that it was 5 bedrooms or 5 or more bedrooms. Out of all of the houses sold, what's the probability that, that statement is true? And so we look, and there's 3 houses that were sold in 2009 that had 5 or more bedrooms out of all of the 258 houses that were sold. Okay, moving on to C. C here, it says the probability that the house was or has 4 bedrooms and was sold in 2013. So, we kind of just look and we say, okay, 4 bedrooms sold in 2013. There were 28 of those. And then there were also, 258 total houses. So that's how we get, I guess, this kind of right here. Okay. So again, probability is just what you want over the total amount. Okay. So the last problem, it says the probability that the house was sold in 2011, given that it has 4 bedrooms. So it definitely has to have 4 bedrooms. So there's 133 homes total that have 4 bedrooms. And it says that it was sold in 2011. So we look at them, or at the chart here, and it says there's 28 that were sold in 2011. So you could go ahead and just say 28 over 133. Or if they don't give you a chart like this, you're going to have to use this kind of equation here. And you'll say, what's the probability that both things happen? Well, 2011, 4 bedrooms, there's 28 out of 258 of those, or out of 258 total. And then this down here, the 133 over 258, is the probability of B, and that's just using this formula here. And the probability of B, the probability of 4 bedrooms, well, there's 133 out of 258 of those. So now to solve this little division here, you have to flip this second one and multiply. So that's what I've done here. And then these two terms, the 258s, they cancel. And you get 28 over 133, which is kind of what we said, right? We said that, there were, in 2011, there were 28 4-bedroom homes sold out of all the 133 4-bedroom homes that were sold. Alright, moving on, we're going to do number 9 here. So number 9, it says that the new iPhone comes in 5 different colors. There are 3 different sizes. So I list, I put like 5 different colors down here, and then I list, some different sizes, the 3 different, like 16 gigabyte, 32 gigabyte, 64 gigabyte, whatever, just examples. And let's see, there's 10 different cases after that. So branching off of each of these 3, we can have, 10 different ones there, 10 different cases, and that would be off of every single one of these, right? We'd have 10 different case options. And this kind of tree here is replicated for every single one of these, right? So how do we solve, how many items are listed all the way off to this side? Well, we can just do the 5 different colors times the 3 different size options times all the cases. Sorry, that's getting a little sloppy, but we just multiply them all and we get 150. So for number 10, it says 5 friends are taking a road trip. 2 of them can drive. So say you put one of the people that can drive in the passenger seat here, or I'm sorry, in the driver's seat, then you would have, you could rearrange the other people. There's 4 options to put in that seat. Once you put someone there, then you have 3 remaining options to put in that seat. Once you put someone there, then you have 2 remaining options to put in this seat. And then you have one last person that you can put there. So then to figure that out, you had 4 options here, 3 options down here, and you just multiply all those together. But there's 2 people that can drive, so now we can put the second person right here in the driver's seat. And if we do that, then we again have now 4 different options to put in that seat, and so on. And so we have this model, the 4 times 3 times 2 times 1, and we multiply that times 2 because there's 2, and I guess I'm getting confused, probably confusing you with these different colors, but there's 2 different ways that we can do that, right? We can do it with driver 1, and we can do that with driver 2. So we multiply this whole thing by 2. And that gives us our kind of answer, our 48 here. Alright, if you have any questions on that, let me know. We're going to move on to the last page here. Alright, so we're moving on to the last page because we had talked about not really knowing exactly what method she was talking about for this third page, the lesson E number 9. So we're going to move on to lesson E number 10, and it's in section E.4, I guess, application of exponential functions. And I just could do kind of a quick rundown through these. For A, it says complete the table. All you need to do is plug the different t values, 1, 5, 10, 15, and 20, into each of the 2 equations, the s of t and the c of t. So you plug 1 in for t on both of those and write down the answer in those boxes, etc. For B, it says what's the vertical intercept for each function? The vertical intercept is where it intercepts the y-axis. So somewhere where it touches the y-axis, and when it does that, all of our x values are 0 because we didn't move anywhere on the x-axis, we're on the y-axis. So we plug in 0 for t. Alright, and what does that represent in the context of the problem? Well, that's just when there's zero money, I guess. Let's see here. Then when there's 0 time. So that's the initial investment. So for B, what does that represent? That's the initial investment because we're plugging in 0 for t. And that means no time has gone by. So for C, and don't pay, let's see, I think I skipped C here because we're just, all you have to do is graph those 2 functions. You can plug that into your calculator or online or whatever you want to do. For D, we have when the 2 would intersect, or when they'd be the same. So you can set those equal to each other and solve for t, or if that's hard to do, you can go ahead and start plugging in values for t in both equations and just kind of see when they're getting close to each other. And then you can kind of dial in on a t value that makes them equal. Alright, so for E, we have which investment would you go with in the short term, less than 10 years? So when t equals 10, which one gives you the more money, more money? You plug in t for the first equation, and do you get a bigger amount than when you plug it in for the second? So you plug in t equals 10 and check which one gives you more. Which investment would you go with in the long term? Well, you can just start plugging in, 25, t equals 25, which is like 25 years or 50 years. You plug in 25 or 50 for t into both of those equations, and whichever one gives you the higher number, then you'd want to take that one after the long term. Alright, so I think that kind of covers it all there. Again, if you have any questions, let me know. And, yep, alright, talk to you later.